before, after the break. Over the floor. Okay, so let me just check the webcast. All right, we're good to go.
We're taking you live to an unbelievable scene in the downtown core where an octopus is clinging to the outside of a high-rise. Experts are unclear as to how this could have happened. Stay with us as we keep you updated on this bizarre event.
Ladies and gentlemen, good evening and welcome to the Oceanwise Seafood Symposium, from fisheries to foodies. My name is Dolph DeYoung and I'm the Vice President of Conservation and Education here at the Vancouver Aquarium Marine Science Center. And tonight, this evening, we're really excited to bring together leaders from across the sustainable seafood industry. From scientists to chefs to fishermen to our own aquarium staff, we all are looking forward to an insightful discussion on the latest developments in research in our marine and fisheries sciences. A special welcome to our members watching in remote locations, including the aquarium's Arctic Gallery, just on the other side of our site here, as well as our friends in the Center for Social Innovation in Toronto right now. All in all, we anticipate up to 280 people participating in this discussion today. So it's been a decade since we started the Oceanwise program, and it seems as though time has certainly flied by. We started with a small group. Chef Robert Clark, who's here and will be speaking today, Harry Cambolis, as well as aquarium staff, including our CEO. We started with 16 partners, humble beginnings indeed, and went out from there to help solve what we felt the greatest issue facing our oceans was overfishing. So in that time, since then, we've stretched across Vancouver. We moved beyond the restaurant industry into suppliers and fishermen. And then in 2009, we extended our reach beyond the Vancouver area all the way to Toronto, where we opened our office there, and today have 2 staff actively working to engage that community, even though they feel a country away from the ocean. Today, we're proud to share we have 600 Oceanwise partners in literally thousands of locations from coast to coast, all people proudly carrying the banner for sustainable seafood. So on behalf of the Aquarium Board of Directors and the staff here, I'd like to thank all of you for participating. We'd like to thank all of our partners, sponsors, suppliers, because without them, this truly would not be possible. I'd also like to take a moment to recognize the Oceanwise staff, past and present, who have truly committed significant portions of their lives to working with these partners to making this possible. So collectively, we're confident we're making an incredible difference to the ocean, rivers, and waterways, and making sure there's going to be fish for future generations. And with that, I'd like to invite the manager of the Oceanwise program, Amory Copping, to go over tonight's agenda for the symposium.
Thank you, Dolph, and welcome everyone, and welcome those that are in Toronto when you hear me. we have 8 amazing scientists that are going to speak to us, and what we're going to do right now is I'm going to introduce the first 4 of them, and then we're going to have a little break, and then we'll have another 4 speakers, just some closing remarks, and then we have a bit of a party for you afterwards. On the back of your agenda, you will notice that there is a survey for all of our OceanWise partners. If you could fill it out at some point, ask us if you need a pen. We'd love to get your feedback from you so that we can design the program for the next 10 years. What do we need to do to continue this journey with all of you and make it even better? So now I'd like to introduce the first 4 speakers. Originally beginning his marine biology career in fish physiology, Dr. Daniel Pauly is one of the world's leading fisheries scientists. Today, Daniel continues his work at the University of British Columbia, where he is the principal investigator for the Sea Around Us project, a 15-year initiative to discover the true catch of the world's fisheries. In addition to research, Daniel has mentored countless students over the years and continues to be very active in bringing marine conservation issues to the public and government level. Kathy Heisey, our second speaker, began her cetacean research over 25 years ago as a light keeper, listening for the sounds of killer whales. She returned to UBC to study the ecology of Pacific white-sided dolphins and continues to be fascinated by them. Kathy is interested in the resident dolphins in the Strait of Georgia, particularly their foraging behavior and prey choice. As a research associate at the Vancouver Aquarium, she studies how dolphins use echolocation to find and pursue prey and to detect and avoid hazards such as gnats. Dr. Wilf Schwartz is a fisheries economist from UBC who has completed graduate degrees under both Rashid and Daniel. He has a sincere desire to better understand the interaction between marine ecology and economics, and his current work includes research into seafood market, price dynamics, and supply chain management. Growing up in Japan, Wilf had a solid appreciation for a diverse array of seafood and hopes that his research will make sure that future generations also get to enjoy seafood. And finally, in the first half, we have Dr. Jeff Marliev from the Vancouver Aquarium Marine Science Center, who has been here for 38 years. His core work is studying the Howe Sound, where he monitors prawn nursery, glass sponge growth, seabed biodiversity, documents lingcod spawning, and studies rockfish abundance, all in relation to Howe Sound in terms of the rockfish conservation areas. And he's even successfully introduced black cod into Howe Sound. So I would now like to introduce Dr. Daniel Pauly, who is going to be our first speaker.
So, good evening. When one gets old, the eyes fade and one sees only the big things. So I will tell you about the big picture for fisheries because I don't see the little things anymore. Where is the arrow key? Yeah, here. Oops. That's there we are. That what you is a boring time series graph is actually the result of a over $10 million project. This is the addition of all the reconstruction that we have done or that colleagues have done. This is the work of 500 people over 12 years, 200 papers, all added up, and the first picture of the world catch. Unfortunately, the FAO, the reported catch, is not drawn in this, but it is about 80 million, the world catch from FAO, and it is flat. It is now flat. The real catch of the world, as we see it, is about 130 million and goes down. Further, this catch is divided up in artisanal fisheries at the bottom, subsistence fisheries, and recreational fisheries, the black line, and industrial fisheries. And this count is about 10 million tons. That image is a challenge to present-day statistical and stock assessment people, because it's very different from the official catch. I will get back to it in a minute. Why is the catch going down, the world catch? Essentially because we fish too much, and here is a compilation of all the effort in the different continents. Account is taken of the power of the engine that are used, and about 2% increase in the efficiency of the engine, and all the of this effort in terms of avionics. In terms of electronics. This is almost like the airplane. In terms of electronics and other devices that improve the efficiency of these vessels by about 2% per year. This is about the effective increase of effort that you experience even when the nominal effort doesn't increase, when the number of boats remains the same. And you see that the most massive increase is in Asia, but also in Europe. Essentially, another feature of fisheries that you don't see in data normally is that fisheries have expanded. I will present that only for one country, Spain, but you must imagine that all countries with distant water fleet have done a similar thing. In Spain, Spain caught in the 50s fish around Spain, obviously, and Canada. And now that's where Spain catch its fish. And you have to imagine the same happening with Japan, the same happening with Taiwan, the same happening with France and China. But it's not the case for countries like Brazil or India, countries that have enormous population that actually have no access to marine resources, or have not claimed this access to marine resource. And I think that it is going to be a big issue in the next decade, the fact that only a few countries make use of the non-coastal resources of the sea. Because of all this fishing effort, there has been major change in the composition of the fish that we land. Essentially, the fish that we land can be characterized with the size, they becoming smaller, or with the position in a food web. And the position in a food web can vary between two, that is herbivores, to trophic level. This is a bit of jargon. It means simply the number of steps up the food web, and 4 or 5 tuna and other large predators have a trophic level of about 4.5, and one can compute the mean trophic level of the catch, of all the fish that you catch, and plot it over time. And it declines massively. And the patterns that happens, many of you have seen this graph, begins always with humans catching the big fish, and that's true for industrial fishing or artisanal fishing. We like big fish, and then after a while they become scarcer, and we catch the middle-sized fish, which have also increased because the big fish are gone. And the medium fish are the former prey of the big fish, and they are also the juvenile of the big fish. That means the big fish are not going to come back because we now fish them down. And this progresses all the time and goes along with the destruction of the environment, symbolized here by the bottom organism. These are not flowers, that become scarcer and scarcer. At the end, you end up with a mud bed that and small things in the environment. That is an environment that is favorable for the development of harmful algal blooms, for jellyfish outburst, and that's what we have in many places of the ocean, a degradation of the ecosystem. And this degradation, we don't notice it. And that's a big thing, that we don't notice it because of a process known as shifting baseline. This is something that I suggested in '95, and it is now quite widely known. Imagine yourself born, say, in one of the generation there. You will, as a young person, you will perceive the world and its diversity, for example, marine biodiversity, a certain way. You will experience it viscerally, personally, and you will know that it is true, that it is like this. And then it will change over time. Over your lifetime, it will change. And you will perceive this change as a loss. Each of us who have lived at a certain place will know stories like that. For example, Jeff will probably know that in a Georgia Strait, link cord are gone. And that will be his personal loss that you can see here. But before we were there, our parents or grandparents or whatever were also there, and they also experienced a loss. But we don't connect with them. And their loss is not ours. That means our baseline is not theirs. The baseline has shifted. The objective baseline that should be there to assess the past has shifted to our own personal level, which is much lower in a case of something that goes down. So we don't know how much we have lost. And when fisheries science, I have described this for fisheries science at first, when fisheries scientists assess what is missing, they always underestimate what is missing because of this effect. This shifting baseline syndrome is very, very, very strong. And it affects also management because when they try to rebuild, when they think of rebuilding, because, for example, in Canada, this is not a government goal. This is so in the US, this is so in Europe, but it's not a policy, an explicit policy to rebuild. But where it is an explicit policy, it's rebuilt only to one generation. So in the US, for example, where there is a policy to rebuild the stocks that have been overfished, they are rebuilt to about the situation in 1980. Now, in '80, most stocks in the US were already overfished. So you have a situation where even your effort at undoing the damage that has been done are stymied by a wrong perception of what the ocean can produce. And that's my last slide. This is really a short presentation, but big scale. If you contrast at the very beginning the fishery for small scale and for large scale, the large scale fishery and the small scale fishery, you get an enormous difference in several indicators. Now, this type of comparison is not performed at a global level because people get stuck in a definition of what is small scale, what is large scale. We have resolved this problem very elegantly. For each country, we take the definition that that country uses. So in Canada, the definition is going to be different from the one in India. But what we have on a large scale and small scale side is always what is the sum of what all countries see happening in their waters. So we have a situation where the large scale do not lend much more, they do more, but not much more fish than for human consumption. You would very much have the impression that it is not so if you look at the scientific literature. If you look at the scientific literature, you have the impression that small-scale fishers work at the subsistence level and feed only themselves. In fact, they are the ones that feed the rural masses in developing countries. This is not the industrial fisheries because the industrial fisheries in developing countries work almost exclusively for export. So the next thing, how about discarding? The discards, this should be corrected. It's a bit lower. It's about 15 million tons. this doesn't account for our latest result. And basically, small-scale fisheries do not have discards. Discards is a moral scandal. That we should not be discarding fish. And in fact, several initiatives exist to get rid of them. Discarding is practiced on a grand scale in Canada, for example, in BC, but it is going to be illegal in the European community. At least our parliament has decided so, not their parliament, because I'm not Canadian, sorry. The catch for reduction to fish meal is 25 million ton. One third or 1/4 of the fish that is caught altogether. This is fish that should not be reduced. Most of it can be used for perfectly good food for humans, direct consumption. The use of fuel for those who are ecologically minded by small-scale fisheries is very, very much smaller by small-scale fisheries because they generally don't go far and they usually often use passive gears. So needless to say, the employment is much bigger in small-scale fisheries. So basically, small-scale fisheries do much of the things that ecologically or socially we want. And therefore, where are the subsidies going? They are going to the big fishery. And that doesn't make any sense. And that is not what we should do. Because for example, if we invested in small-scale fisheries so that they land their fish properly, so that it is sold under hygienic condition and thrown on a beach, they would get much higher value for their fish, and the social benefit would be immense. So basically, that is the big picture of fisheries. Declining catches, an effort that is tremendously increasing, that announces fights, international fights, reason in some countries, in some legislations, that show that you can actually reform fisheries. In the US, I'm pleased to say that the US is actually the country that is now doing probably the best fisheries policies, including rebuilding and controlling effort. And Europe is trying. I don't think Canada is. And we can also improve the key statistics that we have, and we are trying to do that we have for assessing global fisheries. And I think I will leave it at that. Thank you very much. Yeah. The team, that's only some of them, is very international that assembled this, and we have not put all of them because we didn't have all the pictures in the place. So am I okay with the time for questions? Go ahead if you have questions. Jeff?
Would BC's gillnet salmon fishery be considered small salmon?
Is it, the question is whether the BC salmon fishery gillnet fishery is small scale and large scale. I have not done the BC reconstruction, and the question would be what, according to the law, according to BC regulation, is it? That's my question. Is it? I don't know. Okay. Usually, countries use the size of the vessel, which is usually 12 meters. They usually consider whether the boat is owner-operated or not. Usually considered whether the gear is mobile or is moved. If you have a gear that is moved, such as trawl, that's industrial. I think that a set gillnet fishery, if it is owner-operated and from small vessel, would be considered a small scale. Yeah.
That last graph that you had up was very interesting, but not built to support the stochasticity of small-scale fisheries in terms of how frequently it's landed or the scale it's landed?
Well, the stochasticity the small-scale fisheries in many countries shift between species to keep their income steady. They do not target one single species. And while they have stochasticity, if you look at species level, at the aggregate level, they actually vary less than the industrial fisheries, because the industrial fisheries really go after stock until supply lasts. And then it is kind of hit pulse fishing. After 10 years, the stock is gone and they move on. And this is the reason why effort is being displaced from, for example, around Spain to fishing in the whole world, and why effort is moving south toward Antarctica. So strategically, it's actually industrial fishing, which is variable. But tactically, you're right, the small-scale fishes, to ensure a steady income, vary always between the species they target and the gear they use. Yeah? Okay? Yes. Thank you very much.
Thank you so much, Dr. Pauly. If anyone has a space beside them, if you could just move in so that we can bring some additional people in and not disrupt the next speaker, that would be lovely. Thank you, and we'll just bring them in on the sides. And now I'd like to introduce Kathy Heisey, who's going to join us.
Well, hi, and it's quite an honor to follow after Daniel Pauly, who was one of my professors when I was a graduate student at UBC. So I'm here to talk to you about underwater noise, and this is one of my childhood heroes, Jacques Cousteau, who those of you who have a little bit of gray hair may remember. He believed that people would protect what they love, and so he would make movies, and he made a movie called The Silent World in the 50s, but that's one of the few things he got wrong, because the oceans are far from silent. Now, as Anne-Marie said, I've been listening to the sounds of whales and dolphins for decades as a lightkeeper and then as a researcher, using an underwater microphone or a hydrophone. And what I'm going to try to play for you this afternoon are the sounds of resident fish-eating killer whales. These whales are communicating all the time, back and forth, making noise. And if this works, you're going to hear an example of what we call acoustic masking. I love these sounds. What happens? A boat comes around the corner, and they can't hear them, we can't hear them, it's an issue. Now, we're kind of in the stage with the underwater noise issue where we were in the 60s, when we realized that humans were being impacted by airport noise, airplanes, cars, highways, what have you. And as a result of that, we came up with noise standards. So for any of you who work in an environment with machinery, the noise standards are now you can listen to 85 decibel sounds for up to 8 hours a day, but just 15 decibels louder, 100 decibels. The maximum exposure time is 15 minutes. This is a logarithmic scale, so every 3 decibel increase is a doubling in intensity. It's also important to appreciate that sound travels much better in other substrates than it does in air. You know this if you've been in a lightning storm where you hear the lightning and then later you hear the thunder. Well, in air, it travels at 300 meters per second. In salt water, about 1,500 meters per second, but also important to appreciate for those of you that love fish, because they're impacted by this as well. Limestone and other rocky substrates up to 6,000 meters per second. Also, what's relevant is that low-frequency sound travels great distances, thousands of kilometers. A 100 hertz signal can travel thousands of kilometers with virtually no loss in sound energy. Now, marine animals have evolved in the water environment to use sound in a wide range of ways. And I'm going to give you an example of that. We have three acoustically and genetically distinct populations of killer whales here in British Columbia. I played a sound of resident fish eaters for you earlier. We also have transients, or big whales, that hunt silently. They rely on surprising their harbor seal, harbor porpoise, whatever whale prey. And so the only time that they make sound is after they've killed something. Most of the time, they need to be able to hear their prey when they're foraging. So this is an example of what you hear after they've killed something. I find it very eerie. And we have a third assemblage of killer whales called offshores, and they make completely different sounds than the resident killer whales and the big whales. And they're making echolocation sounds and calls all the time. None of these assemblages associate with each other. We've had a fabulous thing happen over the last 20 years, speaking of shifting baselines. We have seen a real movement of humpback whales into inshore waters, and we have a relatively new phenomenon of them using sound to coordinate their foraging behavior when they make these rings of bubbles that you see in the left photo. And when you hear that sound, you want to get ready with your camera, because you know somewhere close by you're going to see this group of foraging humpback whales come to the surface, and I'll play that sound for you. Oops, I can try and play that sound for you. So it's an interesting sound, but they really do rely on it to coordinate so that they all come up at the same time. We've also had the fabulous thing happen. You used to have to go to Hawaii or Mexico to hear the breeding sounds that males make. And now their humpback whales are present year-round in British Columbia, especially on the north and central coast, and the males are singing their breeding sounds. And one of the very important areas for them happens to be on the tanker route for the Northern Gateway pipeline. So the largest of whales, fin and blue whales that we have here in British Columbia, use sounds that historically could travel hundreds and thousands of kilometers. And my favorites, well, I'm not supposed to have favorites, but I've worked on white-sided dolphins, and when you hear the sounds that they make, you realize that you can never be grumpy when they're around. They sound like killer whales on helium. This is an expression coined by Donna McKay. Now, they also use sound when they are displaying here visually. To us, it's a visual display. To other dolphins, it is an acoustic display, because the dolphins in the water hear it. And at the Vancouver Aquarium, we're actually looking at, as Anne-Marie said, at the echolocation behavior of Pacific white-sided dolphins, trying to understand why they get caught in nets. So here you see a dolphin that has a gelatin-based eye cup that it's being desensitized to, because eventually we're going to move that eye cup over to cover its eyes, and then ask it to swim around. And I'm going to hopefully show you this very, to me, impressive video of just how good their echolocation is. We've asked Hannah to retrieve the ring that you see, the floating ring that is in the left, and the trainer is putting eye cups on her. We've got 4 rings distributed around the habitat, and she's going to get the signal to go find one of them, and she does. There she goes, she's standing, she's only using sound to find the ring. And there she's got it. And typically it's less than 10 seconds, and these rings are moving all the time. And she successfully retrieved 4 rings. But you guys are a fish and invertebrate crowd, so I thought, here's my chance to play some other sounds. And so they use sounds for many of the same reasons marine mammals do. And this is a sound of snapping shrimp. And believe me, at night, this is an incredibly loud sound. They're just rubbing their claws together to create cavitation. So there are tens of thousands of species of fish, and we know at least 700, around 700, do make sounds, but it hasn't been studied a lot in the last 10, 15 years, but hopefully that's changing, because Sarika Kala-Suzuki, who's David Suzuki's daughter, did her PhD on these little guys here. These are plain-fin midshipmen that are found at a depth of about 400 meters much of the year, but they come up into the intertidal to spawn, and then the males guard the eggs. And they make sounds that are so loud that the residents of San Francisco Bay were actually calling the local government. Oh, no, that didn't work. We'll see if we can get it to go. We might not be able to. Oh, there we go. It's just a constant low-frequency humming noise, but it's very loud. They also growl and grunt to deter potential predators. Another species that all of you would be familiar with are herring, and they produce sound as part of their anti-predator strategies. And this is from Ben Wilson, who did his PhD on them, and described these sounds as fast, repetitive clicks, and earned the Ig Nobel Prize in Science. Now, what's sound and what's noise? Well, it depends on the receiver. So for an acoustician, whales make noise, and for a whale, ships make noise. Now, chronic man-made sound has been increasing in the ocean since the 1950s at about 3 decibels per decade, and a lot of it is due to shipping, but also other human activities. It's hard to really know what impact that's having on marine life, but post 9/11, when all the airplane traffic stopped, and I noticed how much quieter things were, there was a 6 decibel reduction in ambient noise levels in the ocean. People who were studying stress hormone levels found a significant measurable reduction in stress hormones in Atlantic right whales at the time. And as soon as shipping started up, the stress hormone levels went up. Now, shipping also noise reduces communication space, and it's been fairly well studied. There's been a 90% reduction in the ability of fin and blue whales to hear each other off the west and east coast of the US. You can sort of see it visually here, the red areas of communication space. Main sources of vessel noise are cavitation of the ship's propeller, and cavitation isn't good for the boat. It's not good for marine life. One of the other sources of noise are propellers that aren't maintained, and any fouling that accumulates on the hull increases the amount of noise a boat makes. Pile driving and other construction activities make noise, dredging, explosions. But I can show you here a slide. These are fish that have been exposed to pile driving, showing ruptured blood vessels, abdominal walls, internal hemorrhaging, and the air bladder completely destroyed. Seismic surveys are the predominant source of underwater noise in the Atlantic Ocean. These is used primarily for the offshore oil and gas industry. The sounds that they make can blast 50 kilometers into the ocean floor and then come back up again, and this is what can impact fish. And these ships are traveling at 4 to 5 knots, so there's really no way for most species to get away. This shows you the slide of a fish ear that's been exposed to seismic activity from just a very small air gun towed behind a skiff, 20 cubic inches. The larger air guns in the offshore oil and gas industry are over 5,000 cubic inches. Now, these hair cells are important, and more recently we learned of some work that's been done. Hatchery-raised fish actually have impaired hearing, and it's thought to be associated with all the pumps and noise that keep the water flowing. Military sonars are extremely loud, and all of you have probably heard about beaked whale strandings. Well, they also cause squid to strand, and I'll just play a very quick exposure of you. You might want to cover your ears. This is what mid-frequency sonar sounds like. I hate that sound. And we don't know what are the cumulative impacts of all these sounds. It's not just one source of sound going into the ocean. But things are changing. There a bunch of scientists got together and wrote a letter to President Obama in 2009, and now in the US, and again, an example of conservation work that's being done well. Sound and noise are now incorporated into marine plans. The International Maritime Organization now recognizes that underwater noise is a problem and has come up with both voluntary and mandatory guidelines that will help to reduce that. And in Europe, again, the Marine Strategy Framework Directive, they have an assessment, a basic goal that they want to establish quiet oceans by 2020, quieter oceans. And there's a fabulous program as well for those of you in industry called Green Marine, which is an incentive-based program, and they have incentives around ballast water and noxious gas emissions and that sort of thing. And they're now considering adopting noise as one of their incentives as well. So quieter ships would get some incentive, special perk for coming in rather than the noisy ones. So the good news is that ocean noise is not climate change. It's actually something we can do something about. I don't have time to tell you all the things we can do, but particularly with all the increased activity going on in the Arctic, I think we have an opportunity here to get things right. And I'm hoping that that will happen in the future as we move ahead, and increasing awareness. So if any of you are boat owners, tell your fellow boat owners this is something that you should be thinking about if you care about marine life. It's even like shutting off your sounders when you don't need them. So Oh, and that's it for me. Thank you. And yeah. There we go. And are there any questions? Yes. Pardon me? Humpback whales, and some of them are coming up here to breed or to calve. Yeah, no, so historically, and this is your shifting baseline. So the very first whale watching industry in the world was right here in Vancouver on whales that bred here around Howe Sound, Bowen Island area, and a steamship would go out and take people out to see them. So historically they did, but then whalers came in one winter and wiped all 97 whales out, and that was it, and they haven't come back. So I expect the story about humpback whales will change a lot in the next 15, 20 years. We may see breeding here. I could be wrong, but I cannot believe how quickly things have changed with them. It's amazing. It's a good news story, and we need to celebrate those when we have them. Any other questions? Okay. Oh. Okay.
So there are a lot of boat owners in Vancouver, and you touched on it a little bit. What can we do to reduce noise?
Okay. So the question was, as boat owners, what can we do to reduce the noise? Well, for sure, maintaining your propeller and keeping the hull clean will be appropriate, depending on the size of your vessel. And this really applies more to the larger vessels, making sure you have the right size prop and that you're loading properly. Your behavior, certain vessels with certain operators are acoustically completely different than when a different operator drives it. So going in and out of gear, how you shift gears, if you can reduce that. If you're around whales, or as I said, shutting off your sonars. If you're a new construction, the IMO guidelines are available and really worth following if you can. And I want to share with you, I spoke with a former naval architect, so the experts in making quiet vessels, and he said to me that it is actually no more expensive to build a quiet boat than it is to build a noisy boat. Initially, your costs are higher, but if you amortize them over the time that you own the boat, most often it'll actually cost you less because the boat is more efficient. So, okay, thanks very much.
Thank you so much, Kathy. And now we've got Dr. Wilf Schwartz.
Okay, so before I start, I just want to quickly mention that although I was introduced as a fisheries economist, I see myself also as an aspiring baker. So if any of you chefs out there has any good tips on how to make great sourdough bread, I'd love to speak to you later. Anyways, I'm back to the reason I'm here in the first place, which is to talk about my research interest, which is in the seafood supply chain. So the main theme of this conference today is to bring science to the foodies. So I'm going to start by describing what scientists do. And what scientists do is that we build models, which are a simplified reflection of what's going on in reality. And we use these models from anything from coral reefs to solar systems. And in economics, we use it to identify how people behave. And we use these models to hypothesize what are the different relationships, interactions, and we test it against the data that we have in observation. So when I first started to study supply chain, this is the model that I built. We have a marine ecosystem, which is exploited by local fisheries, and then supply the domestic or supply the consumer demand. I quickly realized that this is quite an oversimplification. In fact, that supply chain, a fish can go through multiple transactions from fishermen to processing to wholesale and distribution and to the chefs and restaurants before reaching the final consumer. And many of these transactions can take place over different national jurisdictions. The second thing I realized is that within these groups of stakeholders, there are a pocket of people that are passionately interested in attaining sustainability. When you speak to local fisheries, there are people that recognize that what's going on in the oceans. They see that there's changes happening, and they feel like they need to be more sustainable. When you talk to the consumers, there are people that want to have the environmentally sustainable and socially ethical choices. And in the middle, you have people like you who are part of these initiatives to make sure that sustainability can happen. And in some occasions, you see situations where these groups of people who feel about sustainability finding each other and creating a successful seafood sustainable supply chain. But in most cases, they can't find each other. It's not happening. And so that's the main question of what I'm looking at right now. And I think it's mainly because that currently in order to make a good supply chains, you need communications and coordinations. And right now, in the global sense, this coordination and communication takes place through market price. And I feel that market price is not sufficient mechanism to coordinate sustainability. So why isn't the price not the right signal for sustainability? When I go back to my first year economics, I studied the whole idea of supply and demand. And so you have consumers who decided they wanted to eat certain types of fish. And based on this demand, to the fishing pressure to exploit the resources, the fishermen catch the fish, supply the market, and then you have this transaction, which then creates market price. As the demand for fish increase, the fishing pressure on the resource increase, which drives the activity of the stock down to the point where stock is now overexploited, and so the cost of fishing increase because you need to spend more time looking for these fish. And as the fishing costs increase, the price goes up, and then the demand should respond by easing off, and that reduction in demand should put some kind of brake on the fishing pressure. But that's not happening, and mainly that's because fisheries now operate in a global context. And in fact, seafood is one of the highest traded food commodity in the world. About 40% of the total catch enters the international market. And if you take into account high sea fisheries, then it's more likely that the majority of fish that's being caught are being consumed somewhere else. And this globalization occurs through many reasons. First of all, the transaction costs and transportation costs went down. The technology has evolved to allow processing and high-level packaging and transportation. And this allowed some of the processing to be done offshore, outsourced into different countries. And so because of these reasons, the fish are going through multiple areas. And my colleague and I describe the situation as masking, diluting, and drawing out some of the signals that's coming out from the environment to the consumer. And what do we mean by that? Masking refers to the idea that because of the new technology that's coming in, we are becoming very efficient at catching fish. And so even though the stock is being reduced and the cost of fishing should be going up, because of these new technologies, you're not really seeing the change in the catch, and therefore it's not really coming into the price. Secondly, dilution means that now the fisheries now operate in global scale, as Daniel mentioned earlier, and that these markets are very tightly integrated. So if you see a reduction in one stock, you can easily go to the other, find a substitute from different part of the world, or sometimes from aquaculture, or even substitute by switching between species. And finally, drawing out refers to the idea that the price of fish influenced by other factors, such as subsidies, which is something that I did my PhD on with Rashid earlier, and different fuel price. And these factors also impact the final consumer price. And so by the time the consumer sees what's in the market, the signal that they should be seeing that something's becoming more scarce and therefore the price should be going up, that's not being observed by the consumer. And why is this a problem? It's because we see all this media information about the peril of ocean and this overfishing, but when the consumer goes to the market and see the choice and diversity of options available at fairly reasonable price, what they observe and what they hear is not matching up, and that's causing a problem. I see it as a problem. And so colleague and I went out and got some data from the North Sea and UK market to try to see if our model matches what the data says. And so I know the dots are quite small. So what I'm trying to show is that as you go from the stock of cod, the number of cod in the ocean, all the way up to the final price, you see that the relationship between the two factors are getting less and less related. So the tighter circle means pretty tight, strong correlation, and a big circle, wider circle means it's weak correlation. And you can see by the time you get to the final retail price, what's happening in the ocean, which is the decline of cod stock in North Sea, is not being reflected in the price. And so we came up with three main approach to addressing this. The first is through the publicity campaign, which is basically trying to raise the awareness in the consumer and create, I guess you would call it foodies, who are conscientious about their options and their food sources. The second approach is to improve the transparency, so make the information available through market-based certification program, such as the Oceanwise program here. And finally, we have to recognize that as in a global context, that we are starting to see this emergence of big central market actors that can have a huge influence on global fisheries. And so, like as I mentioned, the first two components, the publicity campaign and the market-based certification program, there's lots of groups that are pushing these initiatives, and we have seen a huge progress over the last decade or so. And so how do we then create incentives for these big central actors to move forward? And for me, I see that I see corporate social responsibility as a main tool to ensure this, to create these incentives. So I'm going to take, I guess, a couple minutes to discuss what my actual research right now, which is this idea of corporate social responsibility in seafood industry. So the whole idea of corporate social responsibility is a concept that's probably been around for about 40, 50 years, and it's the idea that the corporate self-regulations beyond a minimum standard that's required by the law. And there's lots of ethical and economic reasons to do this, things like corporate altruisms or philanthropy, to more economic reasons like corporate profile and reputation. And effectively, for me, what's most important about this whole idea of corporate social responsibility is that it provides, it's a mechanism for corporation to attain social license to conduct business from the community, both in the area where they operate, actually run the business, and from the consumer. And unfortunately, there's been lots of studies that try to identify this impact and the performance, and the evidence so far suggests it's very mixed. Sometimes you see impact of it, but sometimes it feels more like a greenwash. So I'm currently trying to create go through CSR policies of the top 150 seafood companies worldwide, compile the company profile and compare them with their CSR policies, identify what are the main attributes of these policies from environmental concerns, something like environmental sustainability, to community. So that would include something like the human rights if they're operating in developing countries. Employment would be worker safety, fair wage, and so on. Transparency would be the whole idea of transferring the information, and ethical dimension. And I try to compare what's going in terms of policy, what the companies say they're doing, and what's actually being practiced. How are they reported? Are they just a website that just says, this, we believe in sustainability, or do they actually show the listing of type of programs they implement annually? What are their auditing mechanism? So that we can be assured that what they're saying is what's actually being done. And finally, trying to identify who are the leaders and who are the laggers in terms of CSR. And so the main finding so far is that the seafood industry as a whole is still lagging behind other natural resource industries such as mining or forestry. And my suspicion, and this is just purely suspicion, is that the reason that seafood is still lagging is because some of the main industry that dominates seafood, main company that dominates seafood industry is based in Japan. And I think the corporate culture in Japan is that they're still highly dependent on government to regulate. And so therefore, their attitude is that as long as we're meeting the government standard, that's fine. But I see the whole idea of CSR as a mechanism to improve and to encourage government to step up their regulation. We know that there's a minimum standard, but that's not enough. And so through these CSR policies, and if you can bring corporation to lead the government, then it makes it easier for government to improve their regulation standard. There's still a problem with the whole idea of accreditation, credibility, and legitimacy of these programs in the CSR. And finally, I want to quickly discuss that I don't see CSR as the necessary alternative to the governance by government. I see it more as a supplement to the way fisheries should be regulated. It's a way for, I guess, innovations and coordination to happen at much quicker level, because I feel private sector is much faster at adopting these strategies if there's a reason for it. And that allows a government to catch up. And so with that, I would say thanks for everybody for listening. And if you have any questions, feel free to drop me a line. Thank you. Yeah. Yeah.
Could you say a few words, please, about the increase over the last decades of illegal, unreported, and unregulated fishing?
Okay.
Because this seems, it needs to be included in your equation.
For sure, yeah. So the question was, how do you account for illegal and unreported activities, which are probably being found to be happening by large corporations that use flag of inconvenience and different types of just masking the true identity of fleet. I can't. So right now, my work so far is basically looking at what each corporation says. And so eventually there should be a phase of trying to match up these reported incidents of IUUs, illegal fishing, and try to link that to the corporations that are responsible. And from that, you can probably start addressing that kind of question. But at the stage I'm not now, I haven't been able to link up what's happening in terms of IUU with these corporations. Yeah.
When looking at the CSRs, how are you differentiating between what's happening with their policies versus what's happening in practice?
So that's what I said. So some companies, like I said, just have a statement saying that we believe in sustainability, while others actually do annual reporting. They use third-party certifications, such as ISO. It's a global standards for, and also MSC and ASC would be another type of certification program. So there's going to be a progression. Ideally, what I'm working on right now is to look at the reporting from over time to see if there's inclusion of these more specific activities and accounting of what's going on. Yeah. Okay. Thank you so much.
Thank you. And from some insider knowledge, we get a chance to test some of Wilf's baking, and so highly encourage that behavior. It's great. Our last speaker before the break is Dr. Jeff Marliov. Please come and join us.
So I'm pleased to be here for the 10th anniversary of the Oceanwise program. I started at the aquarium in 1972, and then in 1981, I started a permanent, continuous program of natural history research in Howe Sound. One of the very first things that I was able to do was to document the nursery habitat for the BC spot prawn. That was back in the late 80s. And then very recently, we kind of got slapped in the face, like a lot of people did, by a sea star wasting syndrome. And so I'm going to talk to you today about a sort of cascade of events from the sea star wasting to urchin barrens and talk about the consequences for spot prawns. Now, at the turn of the millennium, this is an underwater shot that's maybe hard to see, but we had a climate regime shift and there was a population explosion of the sunflower sea star that persisted through that entire decade. And it was pretty upsetting to have to witness because they covered everything. This is a highly predatory starfish. It's the biggest and the fastest of BC's starfishes. And they literally covered everything, and they were really changing the ecosystem a lot. Like, I used to regularly wonder, what on earth can bring this to an end? Well, Labor Day 2013, we got hit in the face with the sea star wasting syndrome, which was so hideous, so disgusting. All divers saw it almost immediately, and it seemed at a particular site to take no more than 2 weeks from this overabundance of sunflower stars to go to just melted piles of ossicles. And so this resulted in an unprecedented level of collaboration between citizen science divers, marine stations, universities, aquariums, and veterinary teams in particular. So it came to center around Cornell University, where their vet school happened to have expertise in the field of sea star viruses, and that was because they were studying a viral die-off of sea stars in the North Atlantic. So sea star wasting isn't really new. When I became a scientist in the 70s, people were saying, oh, the crown of thorns starfish is going to wipe out the Great Barrier Reef. They got sick and died. So it was finally shown that this was a sea star-associated densovirus that caused them to be obliterated. And by the end of October, there were no sunflower sea stars in Howe Sound, and we noticed that there were all these pretty red and green algae growing up. We thought, oh, this will be very interesting. And then we noticed there were these little thumbnail-sized green urchins. So over that winter, we saw an explosion in the abundance of green sea urchins. Now, sea stars and sea urchins are in the same phylum. They're echinoderms, and it is a biological characteristic of these animals that they can have explosive population expansion, and it's not abnormal to see a particular rocky reef looking like this. Very start of my career in Howe Sound, I worked with a couple of urchin barrens where all the seaweeds are gone because of a high abundance of green urchins, but never before have we seen every single rock surface in shallow water in Howe Sound covered with green urchins, and this appears to be true throughout the Salish Sea. This is being seen as far down as California with purple urchins and stuff. Now, a lot of people are saying, oh, the urchins came out of hiding because they were afraid of the sea stars. We're now doing some forensic work with our video footage because although the literature on this species, which comes from the North Atlantic, says, oh, it takes them 5 years to grow up. That didn't happen. These little guys grew explosively over their first winter, gobbled down all the seaweed, and so we're keeping tabs on them. And of course, included in the seaweeds that urchins eat is kelp, and this is a photo of agarum, which is the kelp species that lives deepest in Howe Sound, and it is the exclusive nursery habitat of spot prawns. This is actually just a scattering of blades. They like multi-layered agarum blades, and they're very crinkly blades, and so if you peel them up carefully, you'll see little baby fish and baby shrimp of all kinds of descriptions because they can hide in this kelp. And so after we published this as the nursery habitat for spot prawns, we decided to undertake annual surveys of nursery abundance as a good monitoring tool for Howe Sound. And hey, it's easy, fun diving, so we kept doing it. Now, the urchins eat the agarum, and the big photo is of a bunch of agarum stipes on a reef that was covered with agarum last summer, and we hoped we would see a good abundance of spot prawns, but by luck of the draw, it was a very weak abundance of spot prawns. In the past, we would go to agarum beds throughout Howe Sound, and we'd find high abundance in one place, lower abundance, and some, by luck of the draw, just wouldn't get any settlement. Now there are no agarum beds. So there are two photos here, and I'm not sure if you can see it up there, but That's a garum on the top of a rock pinnacle, and it just has countless well, we count them, large numbers of prawns underneath. And whenever we get a bumper crop, this was taken in 2008, the prawns spill out into surrounding habitat where they're sitting ducks for passing fish and such. And so these little guys are less than an inch long, and by the fall of the year, when there's been a big year class in the nursery habitat, some will have outcompeted others. If they grow big enough, it's the normal life history that they go down into deep water in the late fall and join the fishery population. And the magic number is a 17 millimeter carapace length. When they're really abundant, lots of them aren't that big at all, and we see them overwinter in the nursery habitat and maybe hide in crevices, and by April or May, they'll be big enough to join the adult population. Now, DFO has had its prawn research centered in Howe Sound for the inside waters a lot longer than we've been there. We've always known those guys, and we've always known that their results don't at all reflect ours. They see a very even abundance. It's always been a very stable, reliable fishery, and we think that's because there's an averaging off the nursery habitat into 2 calendar years, and size really is not age for this species. So these photos are from 2008. It happens that 2007 was close to a year class failure as far as what we saw. Another important thing that you have to consider then is that the spot prawn is a protandric hermaphrodite. Hermaphrodite means it changes sex. Protandric means first male. So they function as a male earlier in their life, and then they all turn into females. There are other pandalid species, and I worked for many years with the coonstripe shrimp, which is called a partial protandric hermaphrodite. Some individuals quickly pass through male anatomical characteristics and then function as a female in their first year of life and continue to be females, whereas others will become male and then turn into females. And some individuals will function as a male throughout their life, which means 1 calendar year of birth, meaning a year class, can reproduce unto itself throughout its life without any dependence on year class success in preceding or successive years. That's not the case with spot prawns. Spot prawns are characterized like pink shrimp with really high population abundance, and it just doesn't seem to be a trick they had to evolve. So comes the problem. We saw nursery failure in 2014. What we've seen over this winter looks to us like we're predicting, I'm predicting today that by the end of June we'll have to say, yeah, it was another year class failure. If that happens 2 years in a row, you start to have a population that is becoming all female. If the females can't find males, there will be a negative feedback loop of reproductive failure. And I would anticipate, since we typically see an urchin barren persist for years, that the two problems will compound. So unfortunately, it's kind of a boogeyman story. You know, I hope I'm wrong, but it looks to us like this is a very clear case, and this has been an unprecedented series of events from the sea stars through the urchins to this. DFO does not pay any attention to what we say. They have their own model. They work on what's called an escapement model. And so they see what proportion of the population is female that can bear eggs for the future. So they shut off the fishery if they're seeing a lack of females. So it's sort of an interesting problem if it's an all-female population, and that would seem to argue that you should keep the fishery open. But they do have a category in their data for females not bearing eggs. In my experience, all females have fertilized eggs on their swimmerettes, on their tail, every winter. So they would notice this, and so it would take until 2018 until you would have what I guess would technically be called a fisheries extinction. It's really important to point out that that doesn't mean anything for the spot prawn population in terms of their biological functioning. You very often see, particularly with climate regime shifts, that weird, wonderful little species that humanity has no impact on will just wink out as far as you can see, and then in another climate regime they bloom. So the spot prawn population will probably continue to be surviving in Howe Sound and functioning fairly well, but there won't be enough of them for people to catch for food. So that's the problem, and you know, I'm sorry to be saying a bad news story, but it's something I think we need to keep our eyes open to, and the Oceanwise program will be here and keeping seafood producers and purveyors aware of trends, and with the Coastal Ocean Research Institute, we'll be out there in Howe Sound looking, and it's going to be an interesting time to live in. Thank you. There would be time for a question now. Yes?
I wonder in BC, with herring and salmon and prawns, we seem to fish them when they're in their spawning period, and I find that really unsustainable. But I noticed about a month ago, I had spot prawns, and almost all of them had eggs, and I wonder why we fish them at that time, or why fishermen don't throw the ones back that are loaded with eggs.
So the question has to do with why do we take animals that are reproducing? Why do we see prawns bearing eggs? Yeah, at that time. So the sport fishery, of course, runs through the year, and they're allowed to take egg-bearing females. They try not to open the commercial fishery until May, when the hatching has essentially taken place. So they've been allowed. The purpose of the management plan is to allow females to bear the eggs through the winter period and have the young hatch. So that's the concept for the management of the prawn fishery. But they do carry eggs for a lot of the year. So yeah, it's unfortunate. Mike?
Just a further comment on that. It's different in BC fishery than in the States fishery. In the States fishery, it's open earlier and they can take.
Okay. So that was a comment from the audience that in the States, they do open the fishery earlier and they allow them to take them bearing the eggs. Yes, sir? The question is whether we've propagated them here at the aquarium, and yes, we have. And of course, the model I've just presented to you argues that the spot prawn is the largest of BC's shrimps by virtue of being the longest living, not the fastest growing. So I've done coon stripes, humpbacks, spot prawns, side stripes. We've done them all, and there has been interest in aquaculture, and don't go there. Any other questions? Yes, sir?
I have a quick question. So, what percentage of the fishery comes from the landings from the fishery comes from Howe Sound, and if it's not the majority, how widespread is this pattern?
Okay. The question is where do most of the landings come from, and how widespread is this phenomenon? Well, for the Granville Island fishery, of course, it's really important for the boats to be able to go nip right into Howe Sound and nip back to Granville Island, because it's the most efficient way to do it. And Howe Sound is traditionally the most reliable bastion of the prawn fishery. In terms of the sea star wasting and the urchin barrens, this is in the inside waters, the Salish Sea, Puget Sound, Strait of Georgia. There are places in California and such. This has not been seen north of Vancouver Island, and so boats could easily displace north of the island to continue fishing. Different price structure and such, probably. I think we're out of time. Thank you.
Thank you, Jeff, and thank you for all your questions. We now have a half an hour break, so sorry about the doom and gloom on the spot prawns here, but we do have some tasty salmon for you outside and a few other things. So please enjoy the next half an hour, and we're going to start right back exactly at 5:45 Pacific time, so that our folks in Toronto, who are 3 hours ahead of us, know when we're starting back. Thanks so much. Hello, welcome back, and I hope you all enjoyed that tasty little break. That was just an appetizer. Just wait till the break after this next round. So our next four speakers this evening. First off, we have Shanti Roberts, who's here. He is the science manager of the Seafood Watch program at the Monterey Bay Aquarium, where he's responsible for the scientific robustness of the program while increasing its seafood market coverage and moving the entire assessment process online. Prior to Seafood Watch, Shanti's work has included conservation initiatives for protecting cold water corals, turtles, seabirds, mammals, and forage fish. Dr. Peter Ross is the director of the Ocean Pollution Research Program at the Vancouver Aquarium. He pioneered new techniques to evaluate the effects of pollutants on the health of marine mammals. He is an international expert in the area of ocean pollution and the effect on everything from salmon to BC's iconic killer whales. I have even witnessed Dr. Ross and his family rescuing baby ducklings on the Upper Levels Highway. So it's not just marine items he likes to save. He can tell you that story. Dr. Shannon Balfrey is the director of aquatic animal breeding program at the Vancouver Aquarium. She graduated from the University of British Columbia, where she also did her postdoc research in the area of fish health and nutrition. Prior to joining the aquarium's fish research department, Shannon was researching new finfish species for sustainable aquaculture and is able to continue this work while she's here at the aquarium. And our final science presenter, I've got a special presenter at the end, but our final scientist tonight is Dr. Rashid Sumaila. He is one of the most prolific fisheries economists in the world. His interests are vast, with recent publications covering fisheries subsidies, illegal fishing, application of game theory to fisheries, and high seas management. An eternal optimist, Rashid is often seen chatting and encouraging fisheries graduate students at the University of British Columbia to remain positive and just keep pushing. So, without further ado, Shanti, if you'd like to come forward.
Thank you, Anne-Marie. Sorry for subjecting you to that. Terrible selfie. But I'm glad to be here. Thanks very much for inviting us at the Seafood Watch program at the Monterey Bay Aquarium. I'm particularly excited because I can have a shower in the morning without feeling guilty about it. Bit of a challenge in California at the moment. So, well, we're losing the text a little bit, but perhaps you can see it. So the Seafood Watch program is part of the Monterey Bay Aquarium, the mission of which is to inspire conservation of the oceans. And I think this is the mission for the Seafood Watch program. So I think we're a close partner really with the Vancouver Aquarium and the OceanWise program. And I suspect our goals, both sort of the wider goals for the aquarium institution itself, as well as the Seafood Watch program, are very similar. So for Seafood Watch, it's about sort of doing the assessments necessary to figure out which the relative sustainability of different seafood sources on the market, with a focus of on the US market at the moment, but sort of expanding a little bit, which I'll get into, and then sort of making that information available to consumers, to businesses, in order to expand the sort of market for sustainable seafood. So, on the sort of starts at the consumer side of things, and we get our recommendations out to through social media, through our pocket guides, which have been around for about 15 years now, I think, and by a bit more recently through our website and smartphone apps, and of course with our Seafood Watch spokespersons from chefs and other culinary professionals. And all of this really is about sort of raising awareness amongst the consumers and essentially sort of creating a buzz and maintaining a buzz, really, to create demand so that businesses have a reason to start supplying or providing more sustainable sources. So we're part of the Conservation Alliance, as is the Vancouver Aquarium Oceanwise program, and together we work on the consumer side, on the business side of things, and there's now something like 1,700 unique businesses that are using the Seafood Watch recommendations for their procurements. So I'm on the science side, and that's what I really wanted to get into, especially given today's talks. So right at the moment, we are focused on the North American market, particularly the US, and we've got about 80% of the US market assessed, we think. Very, very difficult to tell exactly, where sources of seafood are coming from on these markets. So, back of the envelope calculation is roughly about 80%. And that amounts to 2,000 different recommendations, which are avoid, good alternative, or a best choice, the most sustainable. So in order to do the assessments, we need robust standards. Now, we've had these for 10 years or so, and we periodically need to update these to make sure that we're focusing on the right things. We're taking into account the most updated science and management policies and things that are known to affect the sustainability of different fisheries and aquaculture operations. And right now we're going through a review phase. I bring this up actually because this is one of the ways for people to get involved in providing comments into our program. This year it's going to be it's more stakeholder driven in some ways than it has been in previous years. It's always been a very robust process. We've always had expert input from our science advisory board and things like that. This year, though, we're expanding it out to get much more stakeholder involvement. So all of this is up on our website, and it's a great way to sort of provide comment on the sort of direction of the program in many ways, certainly the standards that we use. So if we're missing something that you think is important, this might be a good time to bring that up. The stakeholder committees, we've broken our science advisory board down into the Fisheries Technical Committee and the Aquaculture Technical Committee. This one's a little scary, the multi-stakeholder committee. This is new this year, and these guys have final decision-making authority as to what our new revised standards are going to look like. Now, all of this is really being driven by our business partners who want sort of additional assurance that our standards are as robust as they possibly can be. And so it's sort of a requirement under the ISEAL Alliance, which you see up here, which is an international NGO that sort of polices these things. So going to be exciting. On the fisheries criteria, these are the 4 criteria that we use. This round, we're probably going to be focusing on making sure that the criteria best take into account the impacts of the fishery on the wider environment, so-called ecosystem-based fisheries management. And we're likely to be looking at the sort of, the various uncertainties that are inherent in the science and management process of fisheries, and just really sort of improve those and make them more robust within the criteria. On the aquaculture side, we've got 10 different criteria. I think the big ticket this time around, this cycle, is probably going to be figuring out a more effective way of assessing the use of chemicals on the wider environment. So it should be really, really interesting. Our next technical advisory committee meeting actually is next week for aquaculture, so we'll soon find out. We're also looking at a couple of new criteria. One is on hatcheries. So this is about the effects of hatchery supplementation, which is used in certain species, particularly here on the west coast, and the effects of that on the wild populations. Energy is a huge one. So this is something that's come up again and again and again that people want us to start looking into, right? So we've got all these criteria, but we're not looking at greenhouse gas emissions or anything like that. So that's where this energy piece comes in. Little challenging to see on here, but just very briefly. On the vertical axis, we've essentially got greenhouse gas emissions per kilogram of edible protein. And you can see sort of working up from farmed mollusks down in the bottom left-hand corner, very low greenhouse gas emission outputs, to an awful lot more for a similar unit of beef protein. And then you can see with the data that is available, which isn't that much at the moment, there are a couple of examples of different areas where tuna are caught with different gears and the difference in greenhouse gas emissions as a result. Highly variable across different targets and different species and different regions. In some cases we've got, I think this is probably nephrops that's being caught in the northeast Atlantic. Very, very high greenhouse gas emissions, even higher than it takes for an equivalent unit of beef. So this is going to be really interesting. It's limited data at the moment. We're going to figure out through the technical advisory committees how best to incorporate this, if at all, in our criteria going forward. Another big part of the program is working to strengthen eco-certification programs. So all of these ones were found a couple of years ago to be equivalent to a good alternative for us. And they're also equivalent to OceanWise, I believe, correct me if I'm wrong, with the exception of some of the MSC certified fisheries, and we have some exceptions there as well. The idea here really is to sort of, help drive these programs to do a better job, identify the good ones, work with the ones that don't make the threshold, and try and improve them, and actually work with the ones that do, because none of these came out green for us, which is the sort of highest level of sustainability that we have. BC spot prawns, for example, green listed. So lots and lots of work to be done here where we can improve the standards that these guys use. This is a really cool one. This is about shrimp, and this is probably there's some people here that know more about this than I, but this is the Association of Southeast Asian Nations. I think there's 10 different countries that are coming together to create a trade bloc, and they're interested in using Seafood Watch standards such that shrimp farmed in those countries meet a good alternative for us by the end of 2015. I think the idea is to get the standard in by the end of 2015. So this is huge. I mean, if this actually goes forward, this is coming up on half of the shrimp that's shrimp imports, I guess, but still, it's a very, very high percentage of the shrimp that's on the US market. Very cool stuff. Lots and lots of interest as well in how to get out of red. So I mean, this is where we see a lot of the businesses that we work with really having an effect on producers. So that there are specific examples now that we've got where they are coming to us and saying, look, I can't sell to the retailers that you guys work with. What have I got to do to get out of this? I want to be able to sell my product. And so we work with them to understand where the problems are, what they need to do to improve, and ultimately sort of improve up through the colours. It doesn't stop at yellow either. So there's a lot that are interested in not just kind of making it halfway. It's making it all the way to the most sustainable, the green listed stuff for us. Lots and lots of interest in this. These are specific conversations that we're having. So in effect, we're having this sort of race to the top, where people not only want to get out of the red listed, but want to move up through a good alternative and to OceanWise, which I think is probably between good alternative and best choice. Again, correct me if I'm wrong. and just basically kind of do this impetus to do these continual improvements that's being driven by all of the work that the Conservation Alliance is doing. A couple of quick things as well. I'm sure I'm 1 minute. So international initiatives. There's conversations going on now in Brazil and in Japan, where there's a lot of interest in using elements of the Seafood Watch program, the standards, I believe, but other sort of things that we've learned basically over the last 15 years of doing this as to, you know, what works in the market here, which may or may not work in other markets, but sort of take some of those lessons, take the standards, even start doing assessments that are important to identify what's sustainable on the Brazilian market and on the Japanese market. This is one of our trainings last year in Tokyo. This was awesome. All right, that's all I've got. Does anybody have any questions? Hi.
Hi. What about a big consumer like China? Do they care there?
I'm sure some do. I don't know. We haven't. I don't know that we've looked much into China. You know, it's only been fairly recently, I think, really, that we've been even looking at Japan. So, you know, I think, you know, I have heard that, you know, once you start working within the region, you might have more luck working in other countries within the region. So you don't necessarily start with the most difficult country first. Hi.
Who is paying for the advisory and the, let's say, getting companies on the right pathway to move from the least desired work towards good alternative, etc., etc.?
Sure. Well, so the work that we do is mostly funded by philanthropic organizations. There are different sort of models across all of the different organizations within the Conservation Alliance. A lot of them get a lot more money from business partners and things like that. But I think what's driving it, really, if I understand your question correctly, is again that there's demand for it now. So where there wasn't really demand perhaps 15 years ago, we're seeing much more demand for it today. So as long as you've got, you know, this sort of continual buzz amongst consumers asking for these things, then there's a reason for business to start, you know, procuring and selling them. Sure, Daniel.
Did you say that the MSC certification is less stringent than any other? Did you say that? I thought I understood that.
No. So yeah, sure. Yeah, the question is whether the MSC standard, I think, is less stringent than any other. I can safely say no, that's not true. There are others out there that the standard is probably not as good as the MSC. But I you know, when we benchmarked it to our standard, for example, it came out as essentially a low yellow. So there's a lot of room for improvement, you know, and we're working with the MSC through their various processes to try and improve that standard. We'd love to see the MSC improve their standard. It's the biggest one. I mean, in Europe, it's really the only real game in town, I think. In the North American market, it's a different story. MSC is not such a big story here. Thank you.
So one online question.
Oh, you've not gotten rid of me yet. So, are there any emerging food trends out there that are particularly alarming from a sustainability point of view?
We've got 10 seconds now.
Can I just say I don't know?
Yeah.
I would say one that concerns me, I think, is that, you know, the sort of the perception of confusion or difficulty amongst consumers in terms of understanding ranking systems and eco-certifications and all this sort of stuff, essentially what's sustainable, what isn't from a fisheries and aquaculture side point of view. The consequence of that being that I'm just going to go and get some other protein source, I think that's a problem. So the more that can be done to simplify those messages and identify the sort of wider ecological concerns with other types of protein production, which is kind of what we're looking at with the energy piece, is going to be an important thing.
Thank you, and now we have Dr. Peter Ross, who's going to join us.
Thanks, Anna Marie. Thank you all. So I think Jeff Marliev gave you a bad news story about spot prawns. I'm going to give you a bad news story about ocean pollution. Bad news because people always look at ocean pollution, they think it's bad news, and a lot of people don't like to think about it or talk about it or do anything about it because it's bad news. But I'm going to argue that we need this bad news because it helps us create good news. And hopefully in my 10-minute slot here this evening, I'll be able to convince you why that is. But first, a distraction. Some of you might have heard a little bit about an oil spill in Vancouver 2.5 weeks ago. This was the motor vessel Marathasa on its maiden voyage. It came over from Japan to load up on grain. It was at anchor in English Bay alongside 12 other freighters and tankers. And it spilled approximately 3,000 liters of bunker C fuel into English Bay. You can see English Bay here on the right. And the challenge that we faced when this happened on a Wednesday night at 5 p.m. was getting that information out. And by the time it was on the news the next morning, that's when a lot of the responsible agencies heard about it for the first time, so 15 hours after the spill. But I think it really serves as a bit of a showcase, a reminder about how fragile our marine waters are and about how a single pollution source or a single accident can change the nature of the quality of our marine environment. And I think for everybody in this audience here today, you can well appreciate that Dungeness crab or English sole or other invertebrates or vertebrates down beneath the surface of these waters, this is a bit of a problem. And when one knows just how long bunker C fuel can linger in our environment, in our ocean waters, then one recognizes that at the end of the day, it's not a single spill that counts. It's the many hundreds, if not thousands of spills that take place every single day in our waters. So being vigilant is obviously important, and being on the ball in terms of the information that's available is also important. In the aftermath of this spill, just to give you a very quick overview, we at the aquarium had 5 major tasks at hand that very first morning, Thursday morning. Of course, we had teams on standby for rescue rehabilitation. We carried out beach surveys for oil. You can see the middle photograph here. Those are barnacles. That was the high tide mark. There weren't too many people out there rescuing barnacles. There were more teams out dealing with oiled ducks and other waterfowl species. We were carrying out marine mammal observations on board a Vancouver Police boat as well as a Vancouver Aquarium boat. We were collecting samples. Of course, we were very concerned about water quality coming into the aquarium because we have a very expensive, very valuable collection, and obviously a lot of staff here, a lot of people out there in Vancouver care about that collection. So there was a direct interest in making sure the water influent quality was good. And then, of course, we were dealing with advice and interactions with a number of different agencies. Many of those were involved in piecemeal in different aspects of this operation. So that's just a bit of a sideline here, a prescript for my talk about ocean pollution, because often school children will think of oil spills very quickly. A lot of the public sees oil spills as a bit of a symptom of human impacts on the ocean. But they're really only a very small fraction of the types of pollutants that are entering our coastal environments, coastal ecosystems. And we tend to have an idea of spills because they're visible, they're point source. We have many other point sources, whether they're smokestacks or sewage effluent pipelines. The point source ones we tend to have a regulatory handle on. We can monitor it, we can understand it, we know the nature of what's getting into the environment, we can document its impact at the local source, we can look at cumulative effects over time or space, et cetera. And if something goes wrong there, we can enact new measures to reduce the release of those contaminant types into the environment. And certainly the more we learn, the more we know, the more we tend to act with regard to the point sources. However, there are many non-point sources. One can think of urban runoff, where we have impermeable street surfaces. We have a lot of different types of contaminants, metals, asbestos, pesticides, hydrocarbons, detergents, et cetera, coming from all sorts of sources in around human cities or agricultural areas. And trying to get a handle on this very complex soup is very, very difficult, but I, for one, think it is very, very important. And I think it's important, and I hope I don't have to convince anybody sitting here today or watching this online, because understanding pollution in our coastal waters is all about ensuring clean and abundant sources of food, seafood. And the more we can understand the way in which some of the 100,000 plus chemicals on the marketplace, the ways in which they enter the marine environment and where they end up and how they move into food webs and up the food chain and get into the tissue of those products that we like to consume or sell or steward in different ways. The more we can understand how those chemicals move into the environment and around, the more we can do something collectively, we, in quotation marks, the royal we, can do something to mitigate, to adopt or design best practices, to encourage the government to enact regulations, or to educate the consumer in terms of their own conduct in our consumer world, or other ways in which some of the stewardship groups like NGOs in our society, what they can do to reduce pollution releases. And when you get all these bad news stories about ocean pollution, to me, it's not just aesthetics, because I get a lot of concern expressed from some of the First Nations and Inuit communities in Canada about the safety of seafood. I get this a lot. I've been having a lot of conversations with different communities for the last 15 plus years. Concerns about PCBs, concerns about dioxins, concerns about mercury, concerns about Fukushima and cesium-134. The flip side to that concern, that apprehension about the safety or the quality of seafood as a result of marine contamination, is that we risk alienating communities that rely very heavily on seafood. And that is, if we could disconnect the Aboriginal relationship with coastal foods, then we are doing a great disservice to their food, social and ceremonial activities, as well as their health. And so can we monitor and do research in support of understanding ocean pollutants in the marine environment in such a way that we can help reassure coastal Aboriginal communities about the safety of seafood, and at the same time inform mitigation? Because after all, that's what we have to do. If we're trying to protect seafood, we're actually, at the end of the day, talking about mitigation of some kind. Just to illustrate how important that Aboriginal question is to all of us, traditional seafoods or seafoods are in so many ways much more important to coastal First Nations than to the average Canadian, or indeed the average American. Average Canadian, average American, down around 4.5 kilograms of seafood a year consumption. 4.5 kilograms of seafood a year. I suspect that's a little bit higher in British Columbia or along the west coast of North America, east coast of North America, but the average, about 4.5 kilograms. If we go up to the Inuit in Arctic Quebec, 110 kilograms of aquatic foods per year, 110 kilograms. So 25 times more aquatic food consumption than the average Canadian. That is staggering. If we look here at some of the work we've been doing in British Columbia, the three middle plots here, near urban communities in around Victoria, British Columbia, First Nations consuming 6 times as much as the average Canadian. And then other coastal communities, 13 or 14 times as much seafood as the average Canadian. So if we're talking about pollution in aquatic foods, or if we're talking about the availability and the sustainability of aquatic foods, we have to be thinking about the 70,000 First Nations in British Columbia that rely very heavily on these resources for their well-being. So what do we do? From my perspective, I need a canary. I need to be able to understand what's going on in the coastal environment around us, and how can I do that? Of course, canaries were used as living indicators of pollutants of a different kind, that being carbon monoxide or carbon dioxide or methane in coal mines. And when the canary died, that was a warning that those miners had to get the heck out of there or put masks on. They had to seek refuge. So the canary warned the miners and helped to save probably thousands of lives of humans. But unfortunately, the canaries never survived this. They fell victim to that. So we've got to be careful with our use of the term canary. But do we have canaries that can help provide early warning indication about the health of the environment? In some ways, there are many species that are used quite routinely. Blue mussels around the US or Europe. We've used harbor seals and killer whales to tell us different things about the environment. And if we can use these canaries to give us a signal, and then we can understand when those different types of contaminants that they hoist up the red flagpole, then we can take steps to control the source. And harbor seals in transboundary waters here of BC, Washington have given us a wonderful snapshot of the health of the coastal food chain. They're eating about 25 different species of fish and invertebrates. They give us a really nice, high trophic level integrated kind of overview of the quality of the food web in the Salish Sea and in the coastal waters of the Northeastern Pacific. And what we see are these four plots for four different classes of contaminants and trends from the early 1980s until very recently. And what you see in the top left are PCBs, polychlorinated biphenyls, probably the preeminent threat at the top of the food chain, the number one concern in the family of persistent organic pollutants over the last 40 years or so. DDT would be a close second. They've been dropping dramatically. They're down fivefold over the last 25 years or so in harbor seals in our waters. What that's telling us is that not only are the harbor seals improving, and we're seeing a reduced risk of adverse effects associated with this class of chemicals in that species, but it also means the food web is improving. This means that a lot of different species of fish, including herring and hake, and a lot of invertebrates have seen some of these similar trend lines. PBDEs, polybrominated diphenyl ethers, top right, you might have heard of these. They're one of the preeminent flame retardants on the market, or have been on the market since about 1980. What we saw in harbor seals over that period of time is a doubling of PBDE concentrations every 3.2 years until regulations in Canada and a voluntary phase-out in the United States in 2004. And I think we're starting to see a little bit of a downtick. And then PCDEs, PCNs, two other classes of very toxic chemicals. My point here is to illustrate a couple of things. First of all, the harbor seal is a wonderful canary that's giving us an integrated overview of the health of the food chain or the food web out there. And a lot of those items that the harbor seals are eating, we would eat as well, has been improving. And the second one is regulations can be very effective. A lot of people complain about implementing costly regulations at some point, and we don't hear the follow-up, we don't hear the good news, we don't hear the environmental response. I'm here to tell you that some things actually are getting better, and harbor seals have helped to tell this story. So as we sort of embark on this journey of science and research and monitoring and of course engagement and stewardship and best practices, I think what we have to realize is that it's all about our understanding what's going on beneath the surface of the ocean. We need to understand, we need those data, we need that in order to protect. And I think food is perhaps the most potent part of this conversation and the most central part of our future when we look at ocean resources and when we try to engage with Aboriginal communities. Because after all, if there's anybody out there who relies more on seafood, it would be those Aboriginal communities that I spoke to earlier in this talk. But this as well is a wonderful topic, I think as everybody knows here, to nurture trust. When one is dialoguing, engaging, extending communications to communities, food is a wonderful way to start sharing and talking about trust, engaging with individuals at the community level, a wonderful way to learn about all the marvelous ways in which food has shaped human cultures here for 10,000 plus years. So thank you for your time, and perhaps we have time for a question. What's your favorite color? Is that the one? Oh, the other one, the second one. Yeah, okay, sorry. What can the everyday consumer do to ensure they are minimizing their contributions to and consumption of marine pollution? Well, that's a good one, and when I was working with the federal government, I always said to public audiences, I said, I'll do you a deal. If you learn what you can do to affect a positive change inside of your household, your home and garden and automobile use, et cetera, I'll do what I can at the federal level to influence policies in support of regulations that help protect the marine environment. So there are many, many things. Obviously, having a toxic-free house and garden is very important. Nobody needs cosmetic pesticides in the yard. I think being a wise consumer in terms of packaging, avoiding those toothpastes and facial scrubs that have microbeads in them. There are lots of different things that the individual consumer can learn about. They can be smart shoppers. They can support a nice eco-friendly home. There are lots of great NGOs and applications that you can download for your smartphone or tablet if you want to shop that way. There are many, many different ideas. So I think this person with this question, probably the first thing is to figure out what resources are available to allow them to do exactly this, and that's be a responsible individual.
Thank you, Peter. And now we have Dr. Shannon Balfrey, who's going to come and speak to us on aquaculture. So there's a couple of questions on aquaculture already waiting online.
All right, well, welcome, everyone. I think I'll put this down a bit. Vertically challenged. Okay. Oh, not that short. I'm going to be talking about some of the research we do here in support of rockfish aquaculture. The Vancouver Aquarium, our mission is all about conserving aquatic life. And I think by talking to you tonight about what we do in terms of rockfish conservation is an excellent example of how we meet this mission. We do have an inshore fishery for our BC rockfish. It is not ocean-wise, not yet, but that includes species such as the copper rockfish, yellow eye, black, and the quillback. They are fished primarily for the fresh market and also for the very lucrative live fish market, which we see in some of our local stores in Chinatown. But the fishery, there are some conservation concerns about this fishery, and they are primarily related to the highly susceptible populations of rockfish. Are very susceptible to overfishing, and these are related primarily to their life history and the biology of them. First of all, the rockfish are very long-lived. Some of them live to be over 100 years. They're very late to mature, sometimes 7 years till they can reproduce. They give live birth, so they don't lay eggs. They give live birth to well over 500,000 larvae when they do give birth. And these are very small larvae, maybe just 5 millimeters long. So they have a tough time out in the field, and recruitment is very poor. The fishermen also like to collect big, old, and fertile fish, and these generally tend to be the big, old, pregnant females. As females get older, they not only produce more larvae, but the larvae are of better quality. So removing these from the populations can have a significant effect. And lastly is they have minimum migration. The rockfish don't really move around a whole lot. So if you find a place where you can get rockfish, you can keep coming back there, and that population is going to be gone before you know it. So what can we do? Well, there are rockfish conservation areas, or RCAs, that have been set up, and the Vancouver Aquarium's had a big part in setting these up, not only creating them, monitoring them, putting out the education and the signage. So these are located along BC, and our House Sound group with Jeff Marliev is involved in monitoring some of these, particularly around the West Van area. But regardless of these RCAs and all the signage and all the education, there's still poaching going on. I, in fact, gave a talk here about rockfish conservation last year and had one fellow walk up to me and say, "Oh yeah, RCAs, that's the best fishing." So he openly admitted to me that that's where he goes and gets his rockfish. So it really is a problem that needs to be addressed if we're going to try and conserve our rockfish here in the inland areas. But I also have another idea, and that is to produce rockfish sustainably, using sustainable aquaculture methods, and this could be an alternative, and we can leave the wild rockfish alone. Aquaculture is booming around the world. It's considered the big blue revolution that's going to save our wild fish populations around the world. And actually, we get over half of our seafood now is now farmed. It's not wild. And this is 2 years ago. The production of farm fish is now exceeding beef production. So aquaculture done right can help solve some of these conservation issues, as well as providing food for a rapidly growing global population. So we thought, well, what should we do? Let's tackle this and see if rockfish aquaculture is possible. So we collected some wild juveniles and brought them into the lab. We got some DFO funding, and we worked at the DFO lab in West Vancouver to, first of all, figure out what do we feed them. We brought them in the tanks, and we started kind of looking at what they eat in nature, formulated a diet. We played a little bit with protein levels, lipid levels, some of the fatty acids that we found out that were absolutely essential. We put those in, and the fish ate it. They loved it, they grew, they did very well. So the next step was to use this, what we called our Cadillac diet, and do some growth studies to try and see what factors were affecting growth performance. So we looked at things like the size of the fish, the species. We were actually working with 2 species, copper rockfish and quillback rockfish. We didn't know that when we brought them in initially because they all looked the same, but as they got bigger, we realized we had 2 kinds of rockfish. So that was good. We took advantage of it. We also looked at individual variation. We used implanted tags into each fish so we could get individual growth performance records. And we also monitored things like temperature and day length. So we did this for a period of about 10 months. And we correlated, and we looked at 3 different size groups of rockfish, small, medium, and large. And we found, and then this is the specific growth rate, and we found that, not surprisingly, the smaller fish grow faster than the bigger fish. But at least this data we were able to collect the information and look at what that performance was and what that growth rate was. We also collected feed conversion data and a whole bunch of other stuff. As far as some of the, and we didn't really see a whole lot of difference between the 2 species for this particular study. We did find, surprisingly, that temperature really didn't have a correlation with the growth performance, and what was significantly correlated with growth performance was actually photo period. So this was new and interesting information, and we could take all this information together, and now we know a little bit more about growth performance and feed conversion, and what can we do if we're growing these in a tank system, what can we do to induce and take advantage of this variation and manipulate it so we can get these juveniles to market faster? Because that's what you do. You have to make this a business model economically feasible. Biologically, it does seem feasible. So the next step of the work was we need to be able to produce the juveniles to carry on from where we just were. So we need larvae and we need broodstock. And essentially what you do is you need to close the life cycle. And this is actually the biggest hurdle in any marine finfish development project for aquaculture, is closing the life cycle. Luckily, we have broodstock here at the aquarium that are very easy to access. They breed in our Strait of Georgia, Pacific Canada exhibit, so we don't go out into the wild for this research at all. We will go out and we stock the tanks for pregnant rockfish. This is in the fall to spring. And then when we spot one, we bring a plate of brownies down to the BC Waters Department and ask them when they go diving next time, will they grab some nets and get that female out for us? So they do, because they like my brownies. And and they bring her into a bucket and we wheel her into the lab, and then we get busy. First of all, each fish, a female in the tank, the exhibit is tagged so we can keep individual records on these females and when they're coming in and their success. And then we put her in these large tanks in the lab. These are, I've got a bigger picture here. These are our partition or our birthing tanks. So she'll be put in here and she'll stay in there for anywhere from a couple days to a couple weeks. Sometimes we actually have to pull her out because we realize she had just been eating a lot and then her stomach comes down. But for the most part, we do have pregnant rockfish that come in. But these tanks are a bit special. We've got a very low inflow of water. We have meshes on the outside screens so nothing can escape. We have a blue LED light that's supposed to give the right blue wavelength that helps the larvae feed. And we have Jeff's invention down here. It's an impeller, and it rotates for a few seconds every few minutes so that the larvae don't settle to the bottom, which is really critical when the birth happens. So we just wait, and then we come in one morning, and this is what we see. This is the mom, and that's all her larvae. And she always gives birth in the middle of the night, so it's a bit of a surprise. So she will immediately be checked over, and she goes back into pack can. We get left with all these mouths to feed. So what do you feed them? This is where the fun starts. Well, basically, we just go back to Mother Nature because she's got it right, and we feed them zooplankton. So we actually dedicate a lot of our time in the lab to growing zooplankton to feed the larvae. So such things as rotifers, artemia, which you may know as sea monkeys, but we grow them in much bigger containers. So we feed those. But the problem with these zooplankton is they're not very nutritious on their own. So we have products such as the spreading product, which is donated to us. We grow the rotifers in these products so they can get the nutrition in them. And we also have a myriad of other products right now out that we can test. We generally get them together, we grind them up in a blender, pass them through a screen. We've got all our little bowls here. And then we harvest our live feed here into buckets, put in some air lines, and then add either one or a combination of them into the buckets. Let them sit for a few hours to overnight, and then that's what we use to feed the larvae. And then we do some science, because we're supposed to be scientists, and we have a series of experimental tanks. And we take the larvae from the larval birthing tank, and we distribute them into these tanks, and we do replicated scientific studies to look at which of these enrichments are actually doing the best job. And best, I mean by gives us the best survival and the best development. So these are the two metrics that we monitor. This is what the mortality looks like. We've got percent mortality here, and yes, that's 100% mortality. And this is the cumulative number. So this one particular birth was over 600,000 larvae. So a lot of mouths to feed. We're coming to terms with trying to figure out what causes this mortality. These are all different births. Some of them are quillback, some of them are copper. We have had success with the copper and 99.9% mortality, or as I like to say, 0.01% survival. But that meant we had well over 100 fish. So when you're dealing with that many larvae, even a small percentage of survival is still something you can use and build upon. So we're quite happy with that so far. We think these populations crash due to insufficient quality and quantity, probably, of the zooplankton that we're giving them. So we're working on that. Progress is slow, but we're patient people. So the next thing we do is we stage them. We look at the developmental stage of them. So that involves sampling in the water column the larvae. We preserve them and look under the microscope. And then we use this scheme that Jeff Marliev has come up with for staging them. And basically you're tracking the development of the caudal fin, the development of the plates, the flexion stage and things like that. This is what it looks like under the microscope. So we stage and look at several larvae at each certain time, at each treatment. It's take pictures, and it's a big job. And this is what some of the results look like. This is a copper rockfish we had in 2013, and this is day 28. So we're staging them here. This is the least developed, and this is the most developed. And at this particular stage, and these are our 3 treatments and the percent of the population, these guys were in between A and D, so early on in the stages of development. And if we look further on, the developmental stages now ranges from A to F. We're seeing less of the blue and more of the yellow, or orange rather. So these are the further developed. So this is where we're starting to see treatment difference. And we go, look at this one. We're seeing a lot more of the ones that are further on in their stages of development. So this is providing some really good information for us as well. So just in summary, we have, as I said, we have had success with copper rockfish. We actually just took this off display. Those were 6 of the ones that survived from a birth last year. That's 0.00001% survival, but there's still a 1 in there. So those are the 6. Right now, actually, in the lab, we have a quillback that gave birth. So we've got quillback larvae in there, black rockfish larvae, and China rockfish larvae. So we've got a nice variety this year we're working with in the lab. And that's it, if anybody has any questions. Good thing I have my glasses on. What is the expected economic feasibility of closed pen rockfish aquaculture compared to wild rockfish? What are the expected reactions from fishermen who will be competing with aquaculture? I'll take the first one. As developing, it's the economic feasibility. As you're developing any kind of aquaculture operation, you always have to try and work with the biology of the animal. So it involves a lot of research to try and figure out what you can do to get these animals in and out to market. Market development is also really important. You know, you don't want to have an animal that you have to culture for 20 years. If you can get it in and out in 5 years, that's kind of what you want to do. So you play with things like good feed, and good temperatures, photo periods, and things like that I already mentioned. As for the expected reactions from fishermen who will be competing with aquaculture, well, they probably won't like it, but they can't keep fishing the seas or there won't be anything left for them, so I'm sure we can all get along. Yeah. Oh, no hormones, no. That's just straight general. And that's feeding the animals to satiation. Oops. Yeah, no, we didn't use any growth hormones, so they were just eating the diets, and we were feeding them to satiation, which means standing there for about 4 hours a day feeding.
So you could produce them in 5 years?
I don't have a crystal ball, but I would sure like to try. Yeah.
My question is, as Has agriculture ever done that? Do you have any evidence to show that when you're able to grow a species, then there's less pressure on the wild?
Do I have an example of using aquaculture to take pressure off the wild? I don't. I can't think of one right now. That's a good question, though.
Sturgeon.
Sturgeon? Is that you, Justin? Yeah. Sturgeon. Thank you. All right, I think that's good.
Okay.
All right, thank you.
Thank you, Shannon. And now we have our final scientist speaking. Maybe he can answer his own question he just asked. That'd be great. So Dr. Rashid Samala.
Thank you so much. Yeah, thank you very much. Now I have the big task of saying something interesting after all the wonderful talks you've had. So let's see how that goes. So essentially, I'm going to talk about economics more. I mean, you've had, in fact, almost every talk had some economics in it, right? So it's just to emphasize certain points. So the classical marine resource management problems, you've heard them all, right from Daniel's overfishing through the pollution, the oil spill, aquaculture efforts. Everything is about the kind of problems we face here. The overfishing and over-extraction of resources, overcapacity, we heard about that. And all of this actually, in general, lead to low profits for industry, yeah, because you have too much capacity going out there. And then you have the pollutants, climate change, ocean acidification, land reclamation, a lot of land-based activities that also impact on marine life and resources. And the thing is, actually, economics predicts that all the things we've been talking about will actually happen. This is the nature of us people, right? When you have a resource which we all access, the tendency is for us to overdo it. And that is why you need regulation, like Peter said. So this is no surprise. I think the big issue we have is how do we move away from these kinds of overuse of resources. And we identify the reason we see this is that these undesirable outcomes that have been talked about all evening is that they are individually rational, and that is where the problem is. It's individually rational to allow too many tankers in English Bay and the Bay here because we are looking at the benefits that we'll get. So that kind of drives the whole thing. And then when you are hit by something, then that's when we start making cry. So we say that this is due to non-cooperative behavior in game theory terminology. So essentially, everybody wants to improve themselves or maximize their own interests, and then you get there. There's a central theme or issue that comes in economics a lot, and that is externality. I know externality doesn't have a nice connotation. It's almost like saying something is out of view. But actually, externality is a concept that tries to capture the fact that if I am fishing and I'm looking only at my benefits or my profits without taking into account the impact of my fishing on all other people in the fishing business or the society, that is what is called externality. I just look at what I get. I don't look at the bigger picture. And externalities can be positive or negative, actually. Positive externalities, when you do something which adds value, I do something for myself and you benefit from it. Think of your garden, beautiful flower of your neighbor. You're going to office and you see that, you love it, it's beautiful, but he or she wasn't thinking of you when they did that. That's a positive externality. And normally, people don't complain about that because it's a good thing. But also, normally, the market doesn't supply enough of that, right? Because you don't capture all the benefits yourself. The opposite is the case with negative externality. So there will be overfishing. And what economics people have talked about incentives, what that means is that actually you tax people who impose negative externality on society. And you subsidize those who impose positive externality. But you will see that as I go in fisheries and most of these things, we do the opposite. We actually subsidize negative externality and make things worse. And you see evidence of this in the catches. Daniel showed you some catches. This is the FAO data. You see there's some stabilization. There's an increase in catch from the 1950s. And whilst that is happening, there's a lot of increase in fishing effort. So if you are an economist and you see this, you start saying, hey, wait here, something is wrong here. Here we are. We're going with more boats, more energy, more people, and we are catching less. That cannot be very good economics. So one of the things we did was to look through data and try to see how profitable are our fishing enterprises globally, actually. Fortunately, this private company puts together data. It collects data for the market, actually, financial market, and so we pull out data there for the top 1,000 fishing companies, operating in 43 countries. And their total gross value, $21 billion. That's about 25% of the gross landed value of fish sold, caught, the ex-vessel value at the dock globally. So it's quite a sizable group of companies here. And we quickly look at their profitability, and this is just one couple of graphs I'm showing you from a full paper. And what we see is that virtually all of them, the companies, are almost not making money or very little money according to that data, which kind of confirms that increase in effort versus the catch you get. And if you try to explain why, one of the things we've identified as a big issue is the level of subsidization of the sector that is going on in various countries of the world. We're estimating about, $35 billion of subsidies to an industry that grosses about $80 billion. So 30 to 40% of your fish is subsidies, A few years back, I did a paper, and the title of the paper is A Fish Called Subsidies, right? Half of your fish almost is subsidies. So, and that drives a lot of that drives too much fishing. So we try to go out in the world and calculate which countries are making money and which are not. Canada actually comes out black with making money. So Canada and the US are okay, but many countries are in the red. The more red you are, the more losses your industry as a whole in this database are negative. So the next thing we try to do is we look at the potential losses globally from the overfishing or the lack of effective management. And this was an estimate, about 10 million tons of fish we estimate are lost to food security because of our overfishing in mid-2000. 10 million tons. Do you know how many mature bulls that will be if you converted in weight? You were talking about aquaculture producing more than our farms. 10 million tons of fish will be equivalent to 10 million fish cows, if you like, right? So in the world we take about 80 million, and Daniel's work is showing that it's actually more because we don't report everything, about 130 million mature bulls if you convert, and that is more than two times or 3 times the production from global cattle farms around the world. So that's a big loss. We need to do something about that. Huge food security implications, thinking of time, I'll just keep going. And so one of the big questions many people ask is, if we have done this overfishing and we are losing so much, should we rebuild or not rebuild? And when we talk about this, the first question I get as an economist, people say, oh, is this ecologically feasible? If we fish down, can we go back? And that is always a question people ask. And even if we can go back, how much effort do we need to cut today in order for the thing to build up? Politicians are very conscious of that, right? Because they don't like unemployment numbers to go up, so that is important. And then how long do we have to wait for this to happen? And then finally, will the net benefit from rebuilding be greater than those of the status quo, the current situation? So these are some of the questions we get. And in general, what nature is very good at is if you leave nature alone, you know what? It comes back, except if you have really overdone it, right? If you've taken out the whole habitat and destroyed everything, then nothing will come back naturally. So we did a paper on this, and actually We saw increases in biomasses, which leads to more revenues and more profits, less cost of fishing because the ocean has more fish, and this is what we found out. In fact, the result shows that you could turn what at the moment is negative net benefit to the global fishing society to a huge positive, from I think minus $30 billion because of the subsidies to about $54 billion of revenue, of profits actually coming in, year out, if we find a way to rebuild and then to manage well thereafter. So, one of the things, in order to start doing, people have given a number of solutions. I'm just going to mention a few. One of the things we keep saying is that the ocean is actually one global ocean. You hear about all different oceans, right? Pacific, Atlantic, Arctic, whatnot. But actually they are interconnected. So we need to start thinking of the ocean as a unit, because what you do in one place will have consequences in many other places. This really comes very clearly when you look at the division of our oceans into high seas and exclusive economic zones, right? The light areas are what are called exclusive economic zones of fishing countries. That is 200 nautical miles away from your coast is your waters according to UN regulations, right? So Canada has the right to manage and take control of the fish within 200 nautical miles. The rest of it is what is called the high seas. And as you would expect, management of the high seas are weaker relatively than management in most countries of within EEZ. So if that is managed badly, you have consequences because the fish move all over, right? They don't need visa to come to Canada, they just go, right? So you need to think like that. And this has led us into a number of analysis trying to see the interaction between EEZ and high sea fisheries. And our conclusion is that really very few species spend all their time in the high seas. They actually straddle in and out of EEZs. And this led us, in a paper we published earlier this year in February, to actually do research that shows that the world could make more money by closing the whole high seas to fishing. I'm saying it quietly because some will go after me. Yeah. So, in fact, if you close the whole high seas, what we are seeing is that we'll get more fish, we'll get more money because it's cheaper to fish close than far. We'll pump less CO2. We haven't specifically looked at that, but it's obvious. And we'll have a better distribution of the benefits of the high sea resources, because at the moment, 70% of the revenues are captured by just 10 countries. Yeah, the Japans of the world, Korea, Taiwan, Spain, and the like. You know, so if you close it, there will be more straddling, and small countries like in Southeast Asia or West Africa will get a bit of the benefit from the high seas than the current situation. So think of the high seas of the oceans as a unit. All right, rebuilding. Usually, most people actually conceptually can see that rebuilding fisheries will be more beneficial. But the big problem is how to move from here to there, you know. So people ask me, why are we not doing it? And I think these are just three things I identify here. The politics of fishing effort reduction is not straightforward. Most politicians will not touch that, right? You know, for obvious reasons. So we need the public, we need society to push them in order to really do something. The waiting time for fish stocks to come back. I gave a talk in Namibia, and one of the fisheries managers said, you are talking about rebuilding. We want fish to feed our people now, you know. It's all about now, right? So waiting time, you have to find ways to transition, you know. And the distribution of costs and benefits are different. Current fishers have to pull back, and future fishers will gain. You have to reconcile those. I know time is going. A few more points. In general, when you look at fish stocks, they are shared, and we know this. The salmon are shared with the U.S., halibut are the same. So one of the ways to deal with this is for collaborative management of fisheries, and there are good examples of that. Halibut is one. The Norwegians and the Russians are managing cod. So that is one recommendation. And finally, I like to put in a word for marine protected areas. I haven't heard that. As an economist, my key reason for really supporting MPAs is that it's like buying insurance to protect us from the errors we make, from the mistakes and surprises and uncertainties. Climate change is coming, we don't know what will happen. I know most of you, those of you who have retirement funds, your financial advisor will not tell you to put all your money in Google stocks, no. And if they do that, just run out of the door, right? They will tell you to buy things that will not give you a lot of return, but will protect you in case the day you wake up and the market is down, you have your bonds to back you up, and that is what MPS can do for you. Thank you very much. The last slide is here. Thank you for attention. And I was talking about fixing economics. I see you standing. Negative profits. Commercial fisheries shouldn't operate if they have negative profit, really, because what's the point? The ecosystem suffers and you are also not adding anything. Some harmful subsidies should be taken away. And there should be policy. Policy should be fixed. I'll leave you with two statistics. One is from Ballard. John Ballard, is he? Robert Ballard. Some of you have heard his name. He gave a TED Talk in 2008. And his opening remark was that if you take the budget of NASA, right, to go to the heavens, all the space work, for 1 year, it is equivalent to the budget of NOAA to look at ocean issues and explore the ocean. The NASA 1 year budget is 1,600 years of the ocean budget. See what I'm saying? Think about misallocation or whatever you call it. 1 year equals 1,600 years, right? So why is this happening? Do people know this? Is that what we really want? The other one is that the new head of science in the European Union, when he was appointed, he gave an interview to Nature and Science. And he said one thing that hit me. He says that in Europe today, if one CEO says something to a prime minister or president, the weight of that is more than 10,000 scientists saying something. So one CEO is 10,000 scientists. Lots of work to do ocean-wise and everybody. Thank you very much. They are tired. I think you are tired.
You just made an interesting point about the amount of loss that happens at sea. And we also see a lot of loss that happens through the supply chain as well after post-harvest.
Yeah.
I'm just curious because there's a lot of discussion lately around how we need to produce more protein for a growing population. Is there a way that we can start to incentivize reducing losses so that we can, rather than produce more, we can use what we're wasting?
Yeah, absolutely. So the question is, there are losses at the level of fishing, which I mentioned, about 10 million tons a year. But there's also a lot of losses in the post-harvest, how we handle the fish, right, until it's on our table. And even when it's on our table, most of the time we don't eat half of the food. You know that. I mean, North America, the developed part of the world. So there's a lot of waste there. The question is, can we do something about that? Reduce that waste. And I think we need to, actually. It's really crucial that we do something about it. I've seen an estimate, somebody talking about 30% at least of the food served is wasted. If we can get the 40%, you see that, 50% maybe, right? So really that is a big chunk, and we will need to find a way to reduce that to almost zero. Okay.
There's one more question. Rashid, what is your best bet for measures that would have traction and be acceptable broadly to change that situation? You have pointed to the drivers of, getting us deeper down into the hole. How do we come out of the hole?
Wow, this is people like to say this is a $64,000 million question. This is a $1 billion question, actually. If anyone has it, then you are made. I think it's going to be a variety of things. It's going to be, and you've heard quite a number from the speakers here. One that has come up again and again is really trying to get people to understand what is going on. I think the communication side is very important. Many of the people don't know. We make a lot of noise, the Fisheries Center, and Peter has done a lot with the oil spill. But you just go out of your circle and ask people, they don't know about these things. So I think reaching out to as many people as possible, the young ones, the kids, will be useful.
One more online question.
Yeah, very good. This is an economics one. How would you incentivize companies to limit or altogether end fishing in the high seas? How will you incentivize? Okay, incentives, when you hear incentives in general, people think of cash or money. There are really many ways you can give people incentives and disincentives, right? One of them is actually to take out the subsidies, because the subsidies are just crazy anyhow you look at it. And a lot of it ends up supporting illegal fishing. IUU fishing has come here. So if you pull that out, then we don't pay part of their costs. And one of the big subsidy types is fuel subsidy, where governments give rebates, and so it's cheaper for you to take your boat out. And so you go further and further away. Take that out. Another thing you can do actually, and at the United, when we did this paper, people were asking me, okay, let's say we accept your results. How do we get it moving? Because we have 10 countries that are really taking all the benefits now. They are not going to take this sitting, right? They're going to push back, and that is true. But at the UN level, you can form coalitions. Already we have tons of countries that really love this. Canada will make more money, by the way. Even the US is one of the 10, but they will make more money by closing because of the large costs they have. So I think you can put together a coalition that will make it uncomfortable for Spain to go and fish there. You know what I'm saying. I like to tell my students, when you're walking on campus at UBC and you throw away a piece of paper, you know, once, you won't do it again. And people don't talk. They just look at you and you won't do it again. So that's the kind of thing. That's social norms, and you can use that also as an incentive to get movement. Yeah.
So thank you. We've had some amazing scientists speak. Here's just a few photos from their slides. So thank you so much to all of our speakers tonight. We inspirational, and I hope the audience online and the audience here has found it as interesting as I have. Now on to our OceanWise partners. We love our OceanWise partners, the OceanWise staff that are all here tonight working. We've got Deirdre and Colleen in Toronto with the OceanWise partners there. We've got Teddy, Claire, Katie, and Loren here with myself in Vancouver. We love your questions. We love the questions where you challenge us about the science behind our program or why there's changes. Or we love the questions where you're asking about sustainable seafood options. We even love it when you tell us about somebody not labeling things correctly. We really do like those questions, so keep them coming. Now, our last speaker tonight, some things have changed in OceanWise over the last 10 years, but one that hasn't is Chef Rob Clark. He's been with us from the beginning, and we are so appreciative of the work that he's done for us, helping us design the program for the OceanWise partners and for restaurants across Canada, but also the work that he continues to do with his partner, Mike McDermott. You could say that the two of them have been the face of OceanWise over the years, and I'd like to invite Rob to come up and say a few words to us.
He's my business partner. Right. Okay, well, I would like to consider myself a pretty confident person, but being asked to speak on a subject I know very little about after 8 people that know everything there is to know about it is a little bit intimidating, so thank you very much, OceanWise, for this wonderful opportunity. It's too bad that Dr. John Nightingale isn't here this evening, that he's off doing important work. It was really, I remember the first meetings we had with the aquarium when we were talking about the possibility of the OceanWise program. And I really didn't. I was doing my thing. I was just whatever. But he said something, and I don't know if John was said it originally or if he got it from somebody, but he said, you know what, Rob, most people don't want to be part of the problem. They want to be part of the solution. And that really inspired me to like it clicked. It's like, you know what, the man is right. That is true. And to help people become part of the solution, you need education, you need outreach, and you need a viable, well, in this case, a program to help people. And I think as chefs, I don't know who I'm speaking to. They're all OceanWise partners, right? Pretty bit for mostly. So I'm talking to the converted, to the choir. I think over the last 10 years we've seen a huge shift in the fundamentals of, or the fundamentally outlook on what sustainability is, or sustainable seafood. 10, 15 years, really. 10 for OceanWise. And it's changing all the time, and it was touched upon a bit about how confusing it can be, and we need, as chefs, we need to hold the course. We have to stay the course. OceanWise is exceptional at being able to make it very easy for us to become a part of something greater than ourselves or greater than our restaurants. I think going to work every day and actually achieving something a little bit more than just, for instance, making a pretty plate will give you much more satisfaction at the end of the day. And what we're doing, what OceanWise is doing, what Monterey Bay Aquarium is doing, what Sea Choice is doing, what everybody else is doing that I haven't mentioned, those are the other NGOs, is working for a positive future. And if we're going to continue to consume fish, we need to look at it responsibly. And as chefs, we're given opportunities all the time. We're on TV all the time. We're in the paper all the time. And I shake my head every time I see a recipe in the newspaper or a cooking demo on television, and the chef is using something that is blatantly not sustainable. And I haven't seen shark fin soup in a while on TV, but it's an opportunity to send the right message, to connect with all Canadians. My mother's a typical Canadian, so I'll give you a perfect example. She'll go to the store and she will ask or buy fleur de sel. This has nothing to do with fish. It's just, she will buy fleur de sel. My mother's never been to France. The only thing she knows about fleur de sel is that she read a recipe in the paper and the chef used fleur de sel, then she's going out to buy that. And we can do the same with sustainable seafood. We have a responsibility. We have a responsibility to our profession. Our profession requires that we have access to high quality food. In this case, we're talking about seafood. And in 10, 15, 20, 25 years, we don't have access to that if we don't take care of that, if we're not part of that solution, opposed to still maintaining to be part of the problem, it's not going to be there. And what we do for a living and what brings us our satisfaction, that opportunity for younger generations is going to be gone. We're not even talking about feeding our children or our children's children. Our profession, that's a whole, I don't have kids, that's a whole different reason to do the right thing. But anyway, OceanWise, I want to thank you so much for everything you've done over the last 10 years. You really made it. Before, well, I was talking earlier, in the late 90s, trying to figure it out for myself, I made a lot of mistakes. And then around 2000, Monterey Bay Aquarium launched their Seafood Watch program that helped me a bit. It was very Americanized, but it helped me quite substantially. And then when OceanWise and Sea Choice came along, it made it very easy as a chef to know that somebody else was doing the legwork and allowing you to cook instead of trying to figure out what's good and what's bad, what's right and what's wrong. And these programs, I think they're important to us, not just here in BC, across Canada. It's even more important it's important to everybody. But as Canadians, I'm proud that OceanWise is a Canadian program. That's something we should be celebrating just in its very essence, that it started here in Vancouver. So anyway, that's enough. Thank you very much.
Thank you, Rob.
My real talk was on spot prawns, but thanks.
You notice Rob didn't go out at the reception. He had to rethink what he was going to say. So thank you, Rob. We have so enjoyed working with you for the last 10 years. And all of the OceanWise partners that are listening to this, we have resources available to you. A number of you started with OceanWise, 8 years ago, 6 years ago, a couple of years ago. What can you do to help further your commitment to OceanWise? Give us a call, look online. We have training, we have materials. We have some materials outside when you leave. Help yourself, talk to one of the OceanWise staff. Please recommit yourself to finding ways to look at your menu, finding more great seafood options, and making sure your staff are trained. You're our ambassadors across the country, and the work that you do is so important to the work that we do and the work that all the scientists do. Here's just some of our founding restaurant partners in Eastern Canada and Vancouver, just to acknowledge all the people that started with us right from the beginning. So thank you so much for your support. Thank you to our speakers today. We have a little a thank you gift from OceanWise that Katie will give to each of you. We really appreciate you sharing your information, your scientific information, and I hope you continue the conversations and have met some new people that are really passionate about sustainable seafood. The OceanWise partners, they create amazing seafood every day, and they have the opportunity to tell the message around sustainable seafood. And if we can connect scientists with the culinary community, we really feel that that is a unique role that the Vancouver Aquarium and the OceanWise program can play in this journey on sustainable seafood. We hope to make this an annual event, and we have more scientists we can bring out. It's amazing, and thank you so much for joining us. Thank you to our sponsors tonight. There's a reception outside, so please go out and enjoy some more of the seafood. Chef Tim Bedford from the Vancouver Aquarium and his team have prepared some amazing sustainable seafood. Ask questions about where it's all from. A number of the producers are here tonight as well. Enjoy, and we look forward to seeing you again to continue this journey from fisheries to foodies again next year. Thank you very much.